let's prove the following. Assume that we have f and g differentiable functions with f of 0 equals g of 0 equals 0, and g prime of 0 is different from 0. We want to compute the limit of f of x over g of x as x goes to 0. So our aim here is to prove that this limit is just f prime of 0 over g prime of 0. So this is a certain form of L'Hopital's rule. So how can we prove this one, and how can we give it some geometric meaning? So one of the examples that we can start with is assuming that we take f of x is sine of x and g of x is x. So here we know that the limit of sine of x over x as x goes to 0 is 1. We're going to see why. So here we check the conditions. So f of 0 is sine of 0 is 0, g of 0 is x at 0 is 0, and g prime of x is 1, which is different from 0. We don't care about f prime. Okay, so here this limit is just f prime of 0 over g prime of 0. So f prime of the sine is the cosine. So the cosine of 0 over 1, and the cosine of 0 is 1. Okay, this means that we have this limit. Okay, how can we prove this result? So to prove this result, let's give it some geometric interpretation. Assume that we have two functions, let's say at 0 here. So both of them verify this condition. Let's say this is f, this is g. So we notice that f of 0 is equal to g of 0. Okay? We assume that g prime of 0 is different from 0. We see it from the graph. So the slope here at 0 is not 0. Okay? So what we can do is we can see that when we try to find the limit, okay, so we just take the slope here at 0 and we take the ratio. So they get very, very close. So the limit is the limit of the slopes. So the ratio of f over g is just the slopes at 0, the ratio, because it's getting very close. Okay, so for the sine, so this is x, this is sine. So both of them equal 0, and the derivative of x prime is 1. It's different from 0. So we can think of this one, the slope here over this slope is the same as the limit of f over g, f over g. Okay, how can we do this one? So taking the slope is trying to find the equation of the tangent at these points. So let's approximate f. Okay, in fact, taking the slope or the tangent is just approximating f and g by their equation of their lines, the tangent line at 0. So let's see, we approximate f by the equation of the tangent line as 0. So it's f of 0 plus f prime of 0 times x. So that's the approximation. So this is the tangent line of f of x at 0. Okay? And for g of x, we have g of x, g of 0 plus g prime of 0 times x. So this is the tangent line, the equation of, so remember, the tangent line is given by f of a plus f prime of a, x minus a. So in this case, our a is 0. So here, because it's 0, we don't need it. So this is for f of x. G of x is g of a plus g prime of a, x minus a. Since a is 0, we have these formulas here. Okay, so we have f of x, let me write it down here, f of 0, which is 0 plus f prime of 0, x, and g of x is g prime of x times x. So here a is 0, A is 0 and f prime of 0, g prime of 0. We don't know anything about f prime of 0. Okay, so now the limit here. So the limit, taking the limit of, as x goes to 0, of f of x over g of x is equal to the limit of f prime of 0 times x over g prime of 0 times x as x goes to 0. Now we can cancel by x since x is different from 0. And we get this one, which is a constant. So therefore, we have f prime of 0 over g prime of 0. Okay? And we assume that g prime of 0 different from 0 because we don't want to divide by 0. Okay? Okay, that's so this one shows what's the meaning here. From geometry, we see that if we draw the slopes or the tangent lines, okay, they have the same values as f over g at the point that we need to study. Okay, we could have done it better. We can make it bigger and see what we can get. So here at 0, this is the tangent, this is the tangent at 0. They look the same. So when we get close to 0, we're just gonna find the ratio of the slopes, okay, at that point. And this is what this one is saying, and it's very helpful. It's very helpful to see, because sometimes you apply it many times. In fact, we will see that we don't stop at f prime of 0 over g prime of 0. We can do more. We can keep going. But for now, this is what we need. Thank you.